This over here is most likely the best mini PC 2025. If you know what a Ryzen AI MAX 395 Plus means, then you know that this is a beast. 128 gigabytes of RAM and a lot more. PCIe slot. So does that mean that we can add the Intel Pro B50, what we just recently checked out in here? Let's go check it out. Now feels like it's been traveled through the jungle because it's taken an arrow through here, but regardless, it's gonna be very, very good. Oh yes. Internal power brick. Wow. A sticker for what? Some screws, some special tweezers for pulling something out, an SSD heatsink, and some washers and some more screws. AI MAX Plus, 2 USB 4s in the front, power button, USB Type A, mic and headphone combo jack. You've got legs on the bottom and on the side, so you can have it either way, which is pretty cool. Then we've got some fan grills on the top. Then on the back, we have the power brick. That's power supply fan then. 2 10 gigabit LAN ports. Oh wow. 2 more USB Type 4s. Guys, remember we checked out the GMKtec's version of the AI MAX 395 Plus, but this one just offers more. The only downside I have here is only 1 HDMI port, not 2 display outs. Obviously USB-C can be display out, but 2 more USB Type A's. There's 2.0 and then 3.0 there as well. Oh my goodness. Okay, we gotta go check out inside. Oh, it just comes loose straight away. 2 screws. And then it just slides off. So this is the top. And then here you can see there's a massive heatsink that blows out through the back. So intake from the top and then out from the back or from the sides, and then goes out from that side. We can see one M.2 SSD slot in there, and then a Wi-Fi and Bluetooth card in there. But actually there is another M.2 slot on this side as well, so you can add secondary slot in there. As you can see, it goes on top of this and then plugs into on that side there. So see that port in here, and then this is the screw hole in there. That's really cool. So you can add secondary M.2. And then looking on the other side, we have a cooling fan for the power supply. Let's have a look at the power supply. The power supply is 320 watts. So that is quite a bit more than the GMKtec actually. GMKtec was 240 watts if you remember that. And then there is a PCIe slot. Absolutely amazing. 2 GPUs, Intel Arc B50 Pro, and it is too thick for this chassis, okay? But then this here, obviously you can change this out because I've got the long version of this. This is RTX A1000. That fits easily in there if you wanted to. But there is a downside. This in here actually is not supported. In fact, this PCIe slot does not support any GPUs. So the PCIe slot there is only for upgrading any more network cards, for example, or some storage perhaps you can put in there as well. But GPUs, unfortunately, that's a no-go. This is really cool, unified one metal block chassis. Honestly, the design just looks absolutely amazing. I guess let's turn it on, do a test if this is actually better than the GMKtec one, because that is one amazing CPU here. It's so annoying. I don't want to pay hundreds of dollars to just change my Windows wallpaper just because my Windows isn't licensed. Well, why don't you try Hookeys? That's a ton cheaper. And if you use the code TN20, you get it even cheaper. What do you mean? How do I get it and how is it possible? Well, see this video here, or the one you're watching. Click in the link on the video description, add the Windows 11 CD product to the cart, proceed to checkout, add the code TN20 for the extra discount. So what, the Windows 11 Pro OEM key is just $23.22? Yeah. Choose the preferred payment option and complete the purchase. The key will be available on the purchased orders in a few moments. Copy the key and paste it into your Windows activation settings, and you're all done. Oh, that was easy. Is that Ryan Gosling?
No.
Anyway, by the way, the same discount code also works website-wide, so go check out other products, maybe like Microsoft Office. Before I'm going to show you the performance of this, I understand that I need to explain something. Why is the AI 395 Plus Max so special and why is it so good? Why is everybody after this? Because there's something very, very special going on with this chip. Now, usually how a computer works, and I've got another example in here, so we can really take a look at that. Please don't fall over. Okay, it's all right. Is let's pretend that this Red Bull can is your operating system where you're, doing some things. On the motherboard, like in here, there's a few different things. We've got our CPU, we've got the RAM, so there's CPU, there's cooler on top. We've got the RAM, and then there's GPU that usually slots somewhere over there. And in order to run the program, it's going to use different things. It either is going to use the processor. The processor, in order to communicate with the program that you're doing, let's say you're editing video or photo, it needs to store some of the temporary files that you're very, very fast using on the RAM. And that's very, very fast memory. And as you can see, there's quite a distance between the RAM sticks and then the CPU that's in there. So usually they would kind of line up like that somewhere inside the CPU or inside your PC, you'd have RAM and then it gets the information in there. So there's a few different levels of storage that your computer need to access in order to run your program. And the closest one to the CPU are the fastest. So inside the CPU, you have level 1, 2, and 3 cache. And cache is basically just another word of memory, RAM, what you have in here. Then you've got RAM, and then you've got a GPU, and GPU has something called VRAM. And that's why you'll notice in a minute why this Ryzen chip here is so special. So your program accesses the CPU, and then there's level 1, 2, and 3 cache. Then if that runs out, it's going to need to store them onto RAM, which is here. And if it needs to use the GPU or send some of the calculations to GPU, for example, LLMs, if you're doing any of your calculations there, large language models, it requires very, very fast RAM. And what they're talking about is memory bandwidth. You need it to be fast because in a normal PC, the problem is that everything is connected so far apart and there's going to be a bottleneck of the bandwidth. How do you connect this RAM to the CPU? And then how do we connect the GPU onto the CPU to make it all kind of talk to each other very, very fast? And this is where Apple recently, with their M chips, made a massive breakthrough because all of these are in one chip. It's also called SOC, System on Chip. All of these things are not separate in here. They're all on one thing. So all of this is in there, and then all of the GPU is all in there. And then the RAM that you have, that's super, super fast, is also VRAM for both the GPU and the CPU. Usually, your GPU only has 8 gigabytes of RAM, 12 gigabytes. If it's good, it's going to be 16 or 24 or even more gigabytes, but they are very, very, very expensive. So what Ryzen here did is follow Apple and put everything on the one chip. If you remember the B-roll from the GMKtec Evo X2, then you can see in there that when we see the Ryzen AI MAX 395 Plus, there's different dies. So they've slapped all of these different things together, which means that the GPU die, which is this tiny little chip inside there, the cooler is in top, they've put them next to the CPU. Even the RAM is very, very close in there. It's so much closer to the CPU than on a usual PC, which makes the communication between all the different parts a lot faster, a lot snappier. And the memory that's usually meant for just CPU now can also be accessed by the GPU. As you can see, this 128 gigabytes of RAM, now that can be accessed by the GPU as well, which means our GPU has a huge benefit of having lots of VRAM that also can be a RAM because it's the same thing. Now it's shared between these things. As you can see, there's a few benefits of this. But your question might be, why is everybody not doing it if it's so good? There are downsides as well. The downside is if one of those things breaks, your whole system's useless. You can't just upgrade your RAM It's non-upgradable. It's all soldered onto the thing, onto the chip, and you can't really repair it. If you want to upgrade your GPU or make it better, you can't add to it. In fact, in this Ryzen AI MAX, you can't even add an external GPU. You can't add to this. That's the downside. Upgradability, very, very minimal. Whereas on this PC, we can upgrade anything. We can put more RAM, faster RAM, we can put better CPU, faster CPU, or a GPU, add multiple GPUs. So as you can see, there's downsides and upsides of everything. But at the moment, because of the AI craze, having lots of VRAM, that is a huge, huge thing, which means you can run locally all of these AI machines. But is it better than the Evo X2? Let's go take a look. So we've got it plugged in over here and we're connected to the screen. So let's take a look. So firstly, if we're looking at the spec, as you can see, our CPU, AI MAX plus 395, and it's got a GPU built into the same chip, as well as an NPU for some more AI built tasks. And you can see we've got 128 gigabytes of memory in use, 8,000 megatransfers per second, available 113. But if you look at the GPU, right now GPU shared memory is 64 gigabytes. So it's kind of split it in half, 64 gigabytes for the GPU, 64 gigabytes for the CPU. So I'm going to run a load, an actual run that our creator might use for Cinebench, and I'm going to take a look how much power are we pushing through and what type of score are we actually getting here. So CPU multi-core score, which basically shows us in here CPU package power, 80 watts, 115 watts, 130 watts. And then if we are going here, I can see that the core clock speeds are about 4.2, 4.3 gigahertz. So usually what happens is when the CPU heats up, the clock speeds are going down because it's a smart system. The higher the clock speeds, basically the more heat we're producing, the faster it goes. So sometimes when it goes hotter, it basically just needs to slow itself down. So we'll see how it does that. See 4.18, as you can see, it's lower than 4.3. And look at that, the package power is 110 now. So it has pulled its power down a little bit. So we'll see what the score is going to be. What's impressive is that this is so quiet. I can hardly hear it, and it's only 63 degrees. The score to beat now for the GMKtec, we got 1,882 points. So let's see what the score here is. Okay, so right now it's 1808. We can see we went only to 64 degrees. It went to 129, but I want to go to the BIOS to actually see if there's a performance setting on. Are we on performance settings or something like that? Okay, here we are, setup. We're gonna go to EC version 0.13 BIOS 103. I updated the BIOS to the latest one. We're gonna go power limit settings. Oh, as you can see, it's balanced. We're gonna go to performance. Thank you very much. Rack is probably a little bit lower, I'm guessing. So we're gonna press save and exit, and let's see if that is any higher. The interesting thing is the GMKtec, the X Evo 1, which is behind there, it had a button, if you remember there, that actually adjusts the power levels. And here we don't have that, so we have to adjust it in BIOS. I don't think a lot of people would probably need it, but I think now we're gonna beat the X2 Evo. Now, if you're wondering how good is the 18,082 score for a CPU, I'm just looking at my benchmark archive. This is faster than the 13900K on desktop or the Ryzen 9900X desktop version. And they pull 200 plus watts from the socket in order to achieve these results. So the 16 cores on this one, this is the best mobile chip that's out there. That's absolutely crazy. So we're gonna do exactly the same test as before. Let's take a look at this line over there now. 136, 160 watts. Now that's what I'm calling performance mode. 4.8, 4.7. So as you can see, we are really pushing this now. Watch, we're going to beat that score. 159 watts. That's absolutely crazy. Okay, it's pulling its power down to 130 now because it thought it was probably getting more I don't know, hot or something like that. But if you look at this line and then the core clock speeds around there, we are a lot higher. So at this point, we were pulling roughly around 100 watts. Right now we're pulling 130 and we started at 160. If we get to 1900, so 1900 points, then we're the 14900K desktop that pulls 300 watts, like double the performance. That will be crazy. And the 7950X is roughly around 2000 points. So I'm super curious where we're gonna line up now. Okay, we did get a higher score, 1876. But the thing is, I'm actually monitoring stuff at the same time, which does take some power as well. So I'm gonna turn that one off, quit Copilot. I hope there's nothing else running in the background, and we're gonna do exactly the same test again. So 1886 is what it got from here. So what I'm seeing is a faster score than the GMKtec, but that is not all why I think this is the best mini PC out there. In fact, I think this is the best Ryzen AI MAX 395 Plus mini PC out there because the connectivity and the features. Now, as you can see, if you put the power mode on and BIOS, it really is a beast mode. You can get probably even more out there because I've been testing this when it's already warmed up, but when it's cooled down, you're probably gonna get even higher scores because it can reach those clock speeds even longer, even better. Then what you have here is 2 USB 4 ports in the front, which is super fast connectivity. That's 2 times 40 gigabits per second. If we are looking at the back, we've got 2 USB 4 version 2 ports. These are 80 gigabits per second ports. 2 in the back, 1 in the front, that's 3 altogether. 2 10 gigabit Ethernet ports right there. That is crazy connectivity into the network. So that's 20 gigabits per second bandwidth for these. Plus, if you add another 10 gigabit card in there, you can get crazy speeds, which is absolutely insane. And on top of that, the actual power is internal, not external. So you're not gonna have a weird power brick. It's just a cable. That's it. Plus the design, overall experience. This is just the best mini PC out there. And I would love if you could prove me wrong in the comment section below. There's nothing better. It's absolutely insane. Oh, and if you're wondering how good is the integrated GPU in there, because we've kind of brushed past this. And by the way, the link's in the description below if you want to pick this one up. The thing is, this integrated GPU is one of the best integrated GPUs that is out there. It delivers roughly laptop variant of RTX 4070 performance on that CPU. Speaking to Benji Kaiser, he was saying that in 3D, sometimes this is better. In some of the 3D scores, this is the best score that he's ever seen on a laptop, which just kind of tells us something about the GPU market and AMD. This is a no-joke GPU. It's really powerful, and I think a lot of people underestimate this, and they need to know more that this is an absolute beast. By the way, if you want to know some of the creative benchmarks, how good this is, I'm not going to redo it in this video. Go check out the GMKtec X2 Evo video, because there I really showed how good this is in creative benchmarks. Actually, I'm going to have to do the LLM test again, because the X2 Evo that I did with the GMKtec mini PC, there was some issues that someone very kindly pointed out in the comment section below. So I'll show you what was wrong and what basically was the issue. So if you remember, on there, we actually saw that everything was done on the CPU, and I suspected that it's just reading it wrong. The task manager doesn't know which is CPU, which is GPU. But there is actually something that we need to do. So if I open LM Studio again, we're gonna do exactly the same models, so you'll see what's happening. So what we can see is I've got the 2 models in there, okay? But maybe you've got the same issue. Basically, click on that cog over there, and when we go to runtime, you can see all of these different things on the side. So my ROCm wasn't updated, so there was an update in there. And then when you go to engines, make sure that we are using the ROCm engine in there. And then basically what should happen is so this is the 20 billion parameter one right now. And if we open this, look at that, GPU is in use now, and look at the speed, 54.7. Previously we were on 11, 12, maybe something like that tokens on the CPU. So that is 4 or 5 times better. But the thing is, if I still go on the 120 billion parameter one, I can't quite load everything up onto the GPU, I don't think. See, it didn't even let me load. Okay, so is it loading? Let's see. It's still loading stuff onto the RAM there, I think. Some people said it's not VRAM, it's the RAM. Well, yeah, it's all just memory together, basically. It's loading it onto the RAM rather than video memory. They're the same thing, like I said. Come on. Oh my word, it just takes so long. Okay, it's probably loading it all onto the memory. So what we'll do is we'll have to go to the BIOS and then move the buffer or the amount it actually allocates to GPU rather than just CPU as well. Because right now it's split 50-50, 64 plus 64 on CPU, GPU. We want to move the needle towards the GPU, so we've got more GPU and memory. Okay, there we go. We found the buffer size, so we're gonna put it to 96. Okay, so now when we go onto the GPU, we can see that there's 96 gigabytes of actually memory in there. Previously, interestingly, it said 2, but it should have been, because the memory in there was 128 gigabytes, but it says, 32 is available. So we're gonna do exactly the same thing. LLM, let's load this one. Everything onto the GPU. GPT OSS 120 billion parameters. Okay, we are running these here. For some reason, it still wants to load it onto RAM. Okay, it has loaded, and right now it's like some of this is GPU accelerated. Let's see what it uses. You can see in dedicated GPU, it's using 31 gigabytes, and it's using the same on RAM, on GPU memory, and normal system memory. It's using the same amount. Processing the prompt, you can see the utilization on the bottom there. Look at the CPU usage now. It went up. So it's still like dividing some of it for GPU, some of it CPU. Can't quite figure out which to use because it's such a large model, 64 gigabytes or so. It was very, very slow. So let's try to load all of this off on the GPU. So I think the LM Studio just needed lunch because after coming back, it just works. Well, actually, there is a few things that I kind of fed it as well. So one of the things was I realized that my date and time settings are completely wrong. So perhaps that was a weird thing. Also, when updating the Vulkan, so I'm using the Vulkan engine rather than Rockham. Rockham doesn't work, Vulkan does. So as you can see right now, I've got 120 billion parameter GPT OSS loaded, 100%, so the 36 model layers are accelerated on GPU, CPU pool size, whatever, okay? So as you can see, we've got it there, and we say, boom, we're working on the GPU, 60.6 gigabytes of RAM used. And look at the speed it's producing this stuff in here. As you can see, CPU is hardly doing anything. Memory there, 32.4 tokens per second. Okay, so let's see. How many watts are we pulling? So GPU is pulling 102 watts, CPU about the same. So I guess hardware monitor doesn't exactly know how to measure CPU, GPU separately. Okay, 30.81 tokens per second. So let's see if we can move it now onto Rockham as well. See if it can do that. Okay, we're gonna load that model. That's 20 billion parameters, let's say dedicated memory. Okay, so Rockham is getting 47.62. So this is GPT OSS 20 billion parameters. Rockham is getting 45.97. Okay, we're gonna go back here. We're gonna load that model. I don't know if Rockham loads on the 120 billion parameters. Let's see if it does. See, it doesn't like Rockham. But if we go Vulkan, then it should load it. Well, as you can see, dedicated memory there. We're around the 60 gigabyte mark now. Look how it fills the system memory and then empties it again. Fills it and then empties it. See how now I think it swaps between RAM and SSD because The system memory is full. It goes on the SSD. Look at the total host reads. We've read 2 terabytes. And then writes almost 1 terabyte. Okay, we have loaded. Everything's now should be on the GPU. Vulkan engine, previously 45 tokens. Okay, so now the bigger model is slower, about 29.7. But I want to know if the Vulkan engine is slower if we go back to the previous model, which would be the GPT OSS 20 billion parameters. The Vulkan with a smaller one, oh, interestingly, Vulkan is slightly faster actually on a smaller one. So as you can see, it can work, but there are a few quirks. If anyone knows what's going on, let me know in the comment section below. So when we're looking at Photoshop, it's absolutely insane. So some of the photographers, you might not even need another one of these. Now, the only one thing that's missing for me from this here is an SD card reader. Micro and full size. If we had that, then we could really make this into an ingest station, portable workstation. I mean, that's just insane. And look at that, I just ran the score again with a little bit of a cooler system, 1904. That is literally the same performance as 14900K at double the power draw. Mic drop there.